practice grid programming questions. Question number 2, in which we have to do the one-hot encoding of a label vector. So I'm not seeing Srinivasan over here. He was very curious about that. Here it is. Give me one moment. Let me share my screen. Okay, I hope my screen is visible.
Yes, it is visible. Yeah.
Okay. So the point where we were stuck is was that where we wanted to find the index. The index of any label in Y in the sorted unique array of Y. Okay, so this is where we were stuck. So there are two possible solutions to solve this problem. One is this one, where this is our Y, 3863. So I'm reshaping it to a column vector. And then we are getting a sorted unique list of all the labels, which is there in U. And then we find the one-hot encoding by equating Y is equal to S and converting into an integer type. Is this solution clear? Hello?
What is S here?
Pardon me. It shouldn't be S. It should be U.
Okay. Okay. It will be U.
Yes, this one. So any confusion how is this one working? Why does it give us the right answer?
Okay, so you are sorting it, then you are taking first unique. So you'll get 368, then you are sorting it. It will come in a sequence, and then you are putting the where you are just assigning the value to 1.
Right. So in the first solution, I'm not using numpy.where. I'm just trying to equate both of them.
Yeah, when you put y equals to u, it's returning a true or false, and for that you are giving the corresponding int value. So it's
Exactly. So the only thing to keep in mind is that array broadcasting will play a major role in this solution. 3863 is going to be 4 by 1 array, and numpy.sort is going to be a dimensional 1 array with 3 elements only, which is 368. So when we are comparing a row vector with a column vector, it is going to broadcast the values and ensure that the two vectors, it will convert the two matrices, two vectors into matrices, so that they are of same shape and they can be compared with each other. And that's how we are going to get this solution.
Okay, so sorry, Srinivasan here. Thank you
Yes,
for
yes.
So this one does not assume, right? The many other solutions that we have had so far, they assume that the index will be, the numbers will start from 0 and go till the last number.
Exactly.
This method doesn't seem to assume that, right?
Yes. This solution does not assume that.
So this is a more elegant method, because otherwise there are other methods that will have many many all 0 columns.
Right.
Okay.
So this is one approach to solve that problem. The second approach is where I was thinking a little bit how to get the index of elements of y in the sorted array u. So again, I made the same mistake. It should be u over here. Yeah, there it is. So in this one, again, we have to go up to this point. We have to get a sorted unique list of labels from y. That's something we have to do. Then we do what we do, we create the identity matrix. So this approach involves an identity matrix indexing. Now this time we are going to get the indices of elements of y in u by this particular statement. Once we get that, then what we can do is we can pass this indices array into and index the identity matrix, and then we can get the one not encoding. Both of these are going to give the same solution. Any questions for this solution?
Okay, so the trick is indices, setting the indices, right? Basically saying that u equal to 1, setting the indices that way. And okay, there's quite a bit of NumPy work here. It
That's
makes
true.
my head spin typically, but yeah, I will write the code and then try it out. And yeah, seems to, yeah. But this is more elegant, right? Because fewer columns.
Yeah, so
you will get exactly the same number of labels as columns, right? You will get 4 columns.
We'll get 3 columns, 4 rows.
Yeah, 3. Yeah, 4. Yeah,
yeah.
The number of unique labels, right? We'll get that many columns, nothing more. Yeah.
Exactly. So both of these solutions can be used to encode any particular label vector into one-hot encoding. So this one I found out to be I was doing some experiments, and this one just struck me. So I thought I should share this one also. Okay.
This is where we kind of almost came here, but we kind of got left. The last part is where we did not finish last time, right?
Yes. That's why I started from here. Okay. And this is also these two solutions are also posted in discourse. So please feel free to go there and try it out.
So there is one more implicit assumption that we are making here is that since the labels are integers, the order in which they are there, so 3 is less than 8, which is greater than 6, which is greater than 3. So for each unique integer, we'll have one column in the output.
Right.
And that ordering of columns also has to follow the numerical ordering of the labels, right? So for example, the column corresponding to 3, if I move it to the extreme right also, technically it's correct, right?
Absolutely, technically it is correct.
So, but for this, I mean, at least for the exam or whatever, I think we're assuming that it will go from lower to higher.
Exactly.
Okay, fine.
Okay. So now let me share another collab. Hi. So the first thing that we are going to do, before we apply our K-NN algorithm is to generate the data. So in this collab, we are going to apply K-NN for classification as well as regression. And we are going to go into details of the K-NN algorithm. We are going to take a look at each and every step and apply and implement that step using NumPy. We are also going to do our cross-validation step and try to figure out what is the best value of K for this particular data set. And then you can apply that method for any other data set also. Okay, so please go ahead and make this make these data points. And let me know once you're done. Is this complete, or can we move forward?
Yeah, I'm just getting some error with the centers. I think I just have to get that correct. It has to be array, right? Array of arrays. Okay, got that. Yeah.
Yes. So let me copy paste this code and share it with share in the chat box, so that we are on the same page, moving onwards. So okay, so I've shared this code so that all of us have the same data set. Okay, now let's move on. So here we are just printing few first 5 points and first 5 labels from the data set. Let's visualize the data set. How does it look like? And you'll find out that this is how it looks like. Okay, now, so we are not going to have a clean separable boundary. As you can see in this one, we are going to get, so somewhere in the middle of the region, we are going to get mixed labels. Okay, let's move forward. Okay, question number 2 is about measuring the distances between any 2 pair of points. So this is at the core of KNN. Our distance measure is going to affect our labeling or our predictions for classification regression a lot. So the first thing that we need to do is we need to find out. So before we find the k nearest neighbors, we have to define a matrix by which we say two points are actually close or far away. And for that, we have to figure out how to measure the distance between any 2 pair of points. So this question asks you to create a function which is called distance between 2 points x1 and x2. And these 2 points are m by 1 vectors. That means they are column vectors. By default, it measures Euclidean distance. It measures Manhattan distance if q is equal to 1. So there's an additional parameter that goes into it. Compute the 2 types of distances between following 2 vectors. Okay, so once you have defined your distance function, you have to compute distances, Euclidean as well as Manhattan distances between x1 and x2, and these 2 arrays are defined as highlighted. So take 5 minutes and write your code in the chat box. Okay, Jadev, I'm seeing your answer. It is actually correct. Can we do it in another manner in which we don't have to write if? NP dot. Yes, we can use that, but without using it. Without
you
using
can just
numpy
pass the
dot.
order to that function and it'll probably.
Yeah, I agree with you. So can we combine these 2 ideas? I mean, can you remove from your implementation the if and else part? Can we do it in a single line?
Yeah. Shubham's answer.
Yeah, that's right. Power of Q.
But absolute also, right?
Pardon me?
You do absolute and then power of Q.
Exactly. That's how we are going to do it.
And another thing is that the square root, right? He has actually posted square root, but quite a few times we don't use the square root, just return the square, sum of the square itself. Right? Which is what should we do? Suppose there is no thing mentioned.
Right. So see, if we want, for example, for this task, when we are trying to actually measure the Euclidean distance, we have to take the square root. We cannot avoid it. However, for k and n, if our objective by measuring the distance between 2 points is just to calculate k nearest neighbors,
just to rank
then,
the points.
Yes. In that case, we can actually ignore taking the square root step. Okay, I've received some answers from Shubham. I've also received answer from Sandeep. Yeah. So Shubham, are you sure that this function is going to work? numpy.abs.
Yes, I tried it, but the distance comes in square, not that.
Not that.
So if we take the distance between, let's say, 2,0 and 3,5,0, the answer will be returned as 9, but the real distance is 3. So
Okay.
The sum has to happen inside the square root, not before you take the square root.
Right. So the the quotient goes outside.
In fact, that square root call also we can avoid by raising the whole thing to 1 by q. That will work for both.
Exactly. So I think this is how it should look like. I hope my screen is visible. So here we take the differences between the two vectors x1 and x2. So we are going to get m number of a vector of m by 1. And then what we do is we raise to the power of q. So before we raise to the power of q, we take the absolute value just in case it is Manhattan distance. We raise to power of q, which could be 1 or 2. We sum along the 0th axis, that is alongside the. So we have a column vector and we are going to add every value and we are going to get a single value from that. If we write x is equal to 0. And then we raise the whole sum to the power of 1 by q. And by this, we are going to get the distance. All right. So before we move forward, can you tell me what is the distance coming for Manhattan? I mean, if you take the Manhattan distance, what is the distance between x1 and x2? Let me ask someone. That would be more engaging. Akash. Akash Yadav. Okay. CS Shruti.
Hi, sir.
Yes, Shruti.
So are we looking at the formula for Manhattan distance?
Mm-hmm.
So that will be the absolute of difference between the both, I don't know, the same index on both the vectors.
Yeah, that is true. That is true. So have you written the code, any code so far? Have you tried this one out?
Yes, sir. This was there in graded assignment last week. Okay.
Okay,
This is
okay, right. So have you written the code right now in this session?
No, sir. I'm right.
You're writing. Okay. Deepshikha. Hello, Deepshikha. Deval Ghai. Okay, Deval. 42.5 is the Euclidean distance. Really? No, it is not coming out to 42.5. 9.21. Manhattan is coming out to be 25, which is right. Or have I made, if your answer is right, then possibly I made the mistake in.
I get 9.21 also.
Yeah,
No,
I'm getting
9.21 only.
9.21.
No, but the thing is that people might have pushed minus 515, so that the x1, x2, right? So that time people can get it wrong. That might be the thing.
Okay. So they will please look at your answer where it is improper, so that you're not receiving the same answer. For Manhattan distance, you're getting exactly same answer. Q. Okay, so please use my version with access equal to 0. So I'm going to copy this and share it with everyone. The reason is that for the next few questions, when we are going to measure the distance from a new point that comes to us, and we want to predict its label, or predict its label, basically, we want to measure distance from that point to every other point in the data set. Okay.
So one question.
Yes, please.
The distance is coming as a array, right? Should be a scalar, no?
Good point. So for now, this is for convenience. Yes, of course, you can write distance 0. But
because
I'm
I don't
not
know
going to write it.
Yeah, because when we get it right, we have to be clear about what should be the return value. Otherwise, we will make mistakes in calculating it, right? Yeah.
Yes, you're right. It should be easy.
Yeah, I think in this case, we're building up to the next step, right?
Yes. That's true. Okay, so now let's move to the next part, next question. So compute distance q is equal to 2. That means Euclidean distance between all the data points and 0, 5. Which is the closest point to this new point? Take 5 minutes.
Can you keep this? What is the point? New point? 0, 2, 0, 5.
Okay, so Jaydev has posted his answer. Anybody else who finished it? Or you want to take a few more minutes? Okay, Devil has also posted his answer. Let me ask somebody. Garima Tanwa. Okay, Jaydev has already answered his. Okay, Manchi Kanti. Mukesh Kumar.
Yes.
Yes, Mukesh. So what answer did you receive?
It will be 4-3.
4-3.
You want the distance?
The distance as well as which is the closest point.
The closest point is 4,3.
4,3. Okay. Okay, we are going to see the answer in a minute. Okay, so before I proceed and answer how we are going to solve task 3, let me go into detail of how we are solving task 1. Sorry, task 2. So I'm going to add some intermediate code over here. Okay, can anyone tell me what is the what will be the shape of x1 minus x2?
10, 1. 10, 0. Reshape, right?
Exactly. So if I write it like this, 10, 1. Why? Because both of them are 10, 1 vectors. Now I'm going to apply each of these operations one by one before I actually build up to the next task. So let me remove this part and this. What will be the shape of this particular thing? Same. This time, okay, if I remove the absolute part, I'm going to get a okay, so I'm going to get a vector in which there are negative values also. But if I keep the absolute, then I'm going to get the positive values only. So that's what I wanted. Raised to the power q. Okay, now let me raise to the power 2. What I'm going to get? What will be the size of my vector?
Same, 10, 1, right?
Same, 10, 1. Absolutely right. And then what I do is I call sum function. Now this is interesting because now I'm going to change the size of my vector. This time I'm not going to get 10 by 1 vector. Can anybody tell me what will be the size of my vector?
Depends on this value. Axis equal to 1 will give a different number. Axis equal to 0 will give 1, 1.
Right, exactly. Because I have only one column and I'm adding all the values of that column and I'm going to get a single value. Therefore, the final shape of my vector is going to be 1, 1. So if I, first of all, if I get that value, it will come out to be 85. And as you can see, there's only one element. So size of that is 1, 1. And to get the final answer, all I have to do is raise to 0.5. This way I can calculate the Euclidean distance. Okay. Now my task is slightly different. This time, yes.
Sir, I'm a little behind on the syllabus, but I want to understand why the Q is a variable. So it's not always going to be 2, is it?
Yeah, it is possibly. So default value, if you don't provide it, it calculates the Euclidean distance, which is, which is equivalent to setting Q is equal to 2. And you can provide any other value also. So the two most popular values are 1 and 2. If Q is equal to 1, we have a special name for that distance metric, which is Manhattan. And if Q is equal to 2, we call it Euclidean distance.
Okay, got
it. So this is how we computed the distance between any two pair of points. Now, let's compute the distance between. Okay, so I could show you the solution, but let's build it up one step at a time. So I'm going to call this new point is equal. Okay, I cannot call it numpy. I'm going to call it new point again. Okay, so numpy dot array. The point is 0, or maybe I could. Okay, just to. Okay, we're not going to see the solution 0, 5. Now, my distance function, I want to use my distance function, which is this one. Okay, so first thing I have to do is this is going to be a single dimensional array. So I have to convert into 2 cross 1. Okay. Now I want to use my distance function and calculate distance between this new point and all the points in the data set. So earlier, if you remember, we kept all our data points into X. Okay. Now let me execute it. So what should be the output? Can anybody guess?
X is the single point, right? Or what?
X is a set of all data points in a data set. Okay, Shubham says that there will be an error.
Unless there is a mismatch, unless there is a match in the dimension, it will be, because you have to implicitly we assume that the same dimension. We are not checking it in that.
Right. So we know the shape of the X is 100 by 2. So shape of this is 2 by 1. Shape of this is 100 by 2.
To transpose one of them.
Good point. So let's transpose. Okay, so let's run it and see what is going to be the output. And yes, there is a mismatch of the two vectors 2 by 1 and 1 by 2. They cannot go together. So let's transpose a data points. Okay. This time it worked. Let's call it some. Okay, let's call it distances from new point. This is the variable, and I'm going to print it. Okay, so we are going to get an array. Of course, we are going to get an array because we are taking one single point, and finding its distance from every other point in the data set, and we have 100 data points. So this array should have 100 data points exactly. Let's check that out. And there you go. There are exactly 100 points. Okay, so this so far what we have done is we have done the first system. Compute the distance between all the data points and 0,5. So far so good. Which is the closest point? Now what we have to do is we have to first thing we have to find the smallest distance to any point in the data set, and then get that point. That means the coordinates of that point. So how we are going to do that? Take few minutes, write the code for this.
Can you repeat the thing?
Sure. So my question is, which is the closest point? Or it should be more specific. What are the coordinates of the closest point?
Oh, that is the task there. It's the same old task, right? And we are doing it with the smaller array or the bigger one?
The entire data set.
The X,
Yes.
okay.
Why I am doing towards that X1 and X2. That's why I'm getting different answer.
Oh, I see.
I club that X1, X2, and then I'm calculating the distance.
Just to be clear, what did we do with the make
blobs?
Yeah, did we combine them into a single array? Did we
No,
stack
not
them?
at all. See. So make blobs, there it is. Here we use make blobs to create our data set.
Okay, so we're calling Y as the second feature. Okay.
Exactly. So Y is the label vector.
Okay.
Okay, Shubham, I'm able to see your answer. It says numpy.min. Okay, minimum distance. Then we get argmin. Okay. Shubham, can you check the second answer?
So I've checked it. I got the right answer.
np.argmin distance, new example. So is it going to give you the coordinates of the closest point?
It is going to give you the index at which the data is minimum.
Right. Then you have to pass that index to
X.
Exactly. Okay, sounds good.
In the code that Shubham has shared, why have we used npmin as well as argmin? Doesn't the second line suffice for finding out the index?
See, even a second line, we have to add one more line to second line. Argmin gives you the index of the, yeah.
Yes,
now
yes,
Jadev has pasted the correct answer. So numpy.argmin is going to give you the index of the minimum value in the array, and numpy.min is going to give the minimum value inside the array. Okay, so we are going to use both of them. Print minimum distance is equal to.
I got confused. Can you just repeat it again? What does min give? What does argmin give?
Sure. So numpy.min is going to give the minimum value of inside that entire array. So this one. Now what we want to do is we want to so that is one part of our problem. Second part of the problem, what is that point which is closest to our new point? So what we want to do is we want to figure out the index of that particular point, which is going to give us this smallest distance, right?
Okay, yeah, got it. Yeah.
Okay, and for that, what we do is we use numpy dot argmin. So corresponding point is not going to be exactly numpy dot argmin. We have to pass
corresponding
it into,
index.
yes, that is the index. Now, if you want to get the point, this is what we have to do. We have to pass that index into our original data set or feature matrix. Then we are going to get the answer that we are looking for. So let me execute it. I hope it works. Yes. So distance comes out to be 0.32 and corresponding point comes out to be minus 0.107 and 4.69.
So I do get a different, I think I have to go look at the blob code, see what I made. Okay, I'll check that. Okay.
Okay. All right. So the solution that I had written earlier is only calculating the index and as well as the distance. That's fine. We can pass this index into the feature matrix X, and we are going to get that row. Okay. Now let's go to next task, which is predicting the label of the new point 0,5 for k is equal to. Now we have a range. It varies from 1, 3, 5 up to 31. Right function predict x, y, k, new point for this particular task.
Sorry, what is k here?
Number of neighbors. Huh?
Oh, each value in k is number of neighbors, is it?
No, I think Mr. Sir has to answer. Yeah, so I think he kind of assumed, but let's get the clarification.
X is clear, y is clear. I think the only point missing is how many neighbors.
Am I audible?
Now you are, yeah.
Okay. I think there was some network issue.
We were asking what is k here because you didn't mention what k is.
Okay. Is my screen visible?
Yes, it is.
Okay. So k has the usual meaning of the number of nearest neighbors.
Is there a way to do this other than that arg partition?
Yes, of course.
So because the arg partition, I still not been able to understand it fully. I know that code
Okay.
works because I can copy paste from the demo video lecture, but I'm not able to understand it fully. Okay, let me try something else.
Okay, sure.
Isn't arg partition similar to quicksort?
Exactly. So arg partition is implemented via quicksort.
Yeah. So if you use the same intuition as quicksort, you'll be able to understand arg partition.
Quicksort or quick select?
Quicksort. Because
Select, right? Because you're selecting at k nearest things.
Yeah, okay. I mean, if you give it a range, it will be yeah, correct. It's quick select. Yeah. Sorry.
I saw your discourse point, but yeah, that is also confusing. I have to wrap my mind around it.
There was a helper function in quicksort called partition that
Okay. I'm getting some solutions in the chat box.
Excuse me, sir.
Yes.
Sir, I didn't understand what K here is.
Okay. So did you get a chance to look through the videos of week 7?
Not yet, sir.
I see. So K is the number of nearest data points from our new point that we take into consideration when we are predicting the label for this particular new point.
Right.
Okay.
Okay.
So the idea is, if the features are similar, then the label should also be similar, right?
Right.
So again, let's take an example of cats and dogs. So you have a bunch of samples or pictures of dogs. Then there comes a new picture, and you want to figure out whether it is a cat or dog. So what you do is you look at the feature from again. I'm telling you it is dog and cat. That makes it look like it's a classification task. But we could have, two unknown animals, entirely unknown animals. We do not know the labels of those animals. And we have only 2 of them. So a new picture comes in and we want to find out whether this is animal 1 or this is animal 2. So what we do is we compare the feature of the new picture with those samples which are already available to us. Okay.
Right. And we know the labels for the already available samples.
Yes.
Sir,
So,
why is K here a range? Shouldn't it be a number like say 3 or 4?
right. So what this task asks you to do is to compute the label of this new point for every value starting from 1 up to 31.
Okay, got it. Thank you so much, sir.
Right. And just a small correction. A moment ago, I mentioned that it sounds like a classification task. Actually, we are solving a classification task. Okay, so your cats and dogs are fine, or any 2 pair of animals is also fine.
Right, okay.
Okay, so I have received two solutions so far. Is there anyone else who would like to share his or her code?
No, I'm getting
Okay.
I the partition part.
So I would suggest you don't have to worry about R partition. Just think about plain sort. That's also fine. For now, of course, when the data set is large, we would like to use R partition.
Sir, suppose we're taking 3 neighbors
Mhm.
and 2 of them have one label and one has another label. Then what happens? We take majority, is it?
Exactly. The majority vote wins. And in this particular task, we will always have one majority because K is always odd. And the number of classes is 2. Okay, let me ask someone. Anirudh? Anirudh, are you with us? Apurva? Okay. Shefali? Saurav Kumar?
Yes, actually, I have joined late, so I have just started from beginning, so just will able to cover up.
Okay, is this Saurav speaking?
Yes, this is Saurabh.
Okay, okay, Saurav. S. Hari Manjunathan? Rishabh Kumar? Rishabh Prakash?
Yeah, working on it.
Okay, okay. Take a few moments. Okay, I think we should proceed now. So instead of looking at the solution, let's build it up. So in the previous task that we did we wanted to get the closest point and the closest distance, whatever that is. So that is a particular case where k was what was the value of k for this
1.
task? Exactly, k was 1. We wanted the minimum distance and the corresponding point, but this time we are actually increasing k from 1 to 31, every odd number between 1 to 31, both inclusive. So this time the task is a bit different. Okay, so now let's copy some of the code from our previous solution. I'm going to copy these two. Okay, right.
Why the reshape 1, 2 of a new point? I want to ask you that time also.
So I think I made a miss. 1, 2
should be
minus. It is going to make it a.
Yeah. No, because you're calling it both of them. Because see, the point should be a column vector, right?
Right. So right. So I initialized it as a row vector, and after that I'm passing it as a column vector.
I understand, but will that make it?
You're right. You're right. It should be just 2 by 1, and no need to take transform here. Is that okay?
Yeah, fine. I just because I just thought we'll be consistent with the convention.
Right. Yeah. Sure. So now what we want is we want to find out. So let's say before we going into tackling the problem for k is equal to 1 to 31, let's try to solve it for k is equal to 3. Okay, so what is the data point? What is the label for this new point? If k is equal to 3, that means we are taking 3 nearest neighbors. So in this case, we have this. Okay, so we have this new point. We have the distance of this new point with every point in the data set. Okay, now we do not want just one value, that is k is not exactly 1. It is 3 this time. So what we want is we want 3. Yes, you got the right answer, or the tool to get the right answer is rsort. So how many of you are not familiar with what is rsort? Please write no in the chat box so that I'll know. There are a large number of people. I will explain what it is. Okay, Shefali says she's not familiar with it. Anybody else? Okay, so let me give you a very quick intro of what is rsort. So let's say I have an array A is equal to np dot array 4 2 4 comma 2 comma 3 comma 1. Okay, and what we want to do is we want to sort this array. So if I print np dot sort, it is going to give me the sorted array, right? But if I type arg sort, okay, it is going to give me the corresponding index of the sorted elements. So see, at index first, the last, so first place is corresponding to the third index, which is since it is 0 based index, so the last element, which is 1. The second element is 2. The corresponding index is 1. Therefore, we are seeing 1 over here. The next element should be 3, and therefore the corresponding index of 3 is 2. Next element should be 4, and the corresponding index is 0. Okay, so arg sort gives you this: the indices of the elements in the sorted array, if the array would have been sorted. Okay, Shefali, is that clear? Okay, so I hope that is clear, Shefali. So let's move on. Now what we want to do is we want to find out the 3 nearest points. Okay, and their corresponding, we'll come to the labels also. So as of now, what we want is the indices of the 3 nearest points. So we can get that by np.arg sort distances. So let's print and see what it gives us. Okay, it is giving some error.
You want to print the entire thing or just 0 to 4, 3?
Good point. So as of now, I'm just printing in the entire thing. So it is giving me the entire array of size 100. Okay, so you can see that all these points are all these entries in this array are unique, and they start from 0 and end at 99. But I'm not interested in the entire array. I'm only interested in the first 3 elements. So I can just print the first 3. Okay, so these are the indices for the 3 nearest neighbors. Now let's look at the labels at these particular indices. Print y and I'm going to pass these indices into my label vector. So I'm getting 0, 1, 1. Okay, so my answer should be what? 0 or 1? Shruti?
1, sir.
Right, because it is the majority vote. Now we have the procedure. What we want to do is we want to put it in proper format so that we repeat it for not just k is equal to 3, we repeat it for k is equal to 1 to 31, all the values. Okay, so for that we are going to write a loop for I in or I can write k also, k in range 1, 32, 2. So this thing I do not have to do it again and again. I can do it only once. Then I have to take first k indices depending upon the value. So now k varies from 1 to 31. So if k is 1, I'm just interested in the first value. K is 3, then I'm interested in first 3 values. Okay. So I can say k nearest indices is equal to this. K nearest labels is equal to y this instead of 3 I would write k. Okay, now since we are solving the classification task, we have to find out the popular vote among all these values. Okay, so one method actually in some of the solutions that you have posted already, it is making use of mode, which is there, which is a function in SciPy. Either we do that, or for this particular method, we can do a quick and dirty solution also, since we know that labels are only 0 and 1.
Just sum them, right?
Exactly. So we can call it y label underscore 1. How many ones are there? We can call it numpy.sum k nearest labels. So this is going to give me the total number of labels. Sorry, the neighbors, number of k nearest neighbors which have
labels equal to 1.
Label as 1. Exactly. Now I have to figure out if this is the most
Greater
popular
than k
value
by
or not.
Yeah.
Exactly. So now there are only two quantities, label underscore 1 and k minus label underscore 1. So this quantity k minus label underscore 1 is going to give me the number of zeros, right?
Yes.
Right. If this is the case, the number of labels of 1 are larger than labels of zeros, then I can print I can safely say print or return whatever I print the label is comma 1. That's it. Or else the label is 0.
So is SciPy going to be available on the portal?
Of course, it will be. NumPy and SciPy both will be available.
During the exam also?
Yes, during the exam also.
What about scikit-learn? Not for this course, right?
For techniques, no.
Okay.
Okay.
So
Question.
So
Yes.
there'll be no creation of data sets in MLT exam?
No creation of data sets in MLT exam. Oh, right. So yes, you wouldn't have to perform the data creation task.
Okay.
Or even if you have to do it, it will be very, very clear. I mean, data creation and doing something on top of that will not be, put into same question. They will be two different steps and therefore two different questions.
Okay. Okay. Thanks.
Okay. So question so far. So maybe I should write for k equals the label is this, for k is equal to this much, label is 0.
What if it is, I mean, there should be a thing, right? What if k is even? So there could be a split vote.
Right. In cases like that, you pick one label either randomly or you consistently pick one label.
So here we are going to pick 0.
So in this particular case, there are no chance of get two labels getting same number of votes
because of the range. Okay.
Yeah, because all the values of k that we have taken are odd.
Okay.
Right. So let's execute this code and see if it runs properly. Okay, so for k is equal to 1, the label is 0, k is equal to 3, label is 1, and you keep moving forward.
So there is a flip-flop, kind of keeps varying, right?
Yeah, it keeps varying. So as of now, we cannot say what is the best value of k.
So then how do you decide what's the best value?
Looking at okay, we are going to come to that point. So before we come, I was saying that at this moment of point, we cannot say which is the best value of k. That's a very good question. We need to find out what is the best value of k for any data set. So that will be the next task. Oh, okay. Maybe not task 5. It is task 6, I think. Okay. So before we move forward, and I'm going to cover that question also, how to choose the best value of k. Are our answers matching? Can you please confirm?
So 0, 111, then 5 times 0, and 4 times
Right.
1, then double 0, and finally a 1. Okay, yeah.
Right, exactly. So I'm also getting the same. Anybody who is getting a different answer?
I'm disagreeing with that on the first point, right? You got the first three indexes 54, 90, 87, 67, right?
Okay, let me.
3.
Yeah, I think I raised that part. Yes, something like that.
First is definitely 54.
No, we keep getting 2, but maybe somewhere I made a mistake in the original data. Fine, I'll come back here. So that way I'm not able to answer this.
Did you put random state in make blobs?
Yeah, I put 42 and then put thing as 1. Let me check. That's okay. So it should be fine.
Okay, so I can take one moment and just copy the code of data creation. That would help.
You actually put it in the chat.
Okay, it is there. Okay, sounds good. Okay, now this is the fifth task, which is about. Okay, so this task number 4, actually asks you to create a particular function. Its name is predict. It takes x, y, and k, and then gives the label of the new point. So this is how it looks like. Now we can use this predict function inside a for loop, which varies from k is equal to 1 to 32, incrementing k by 2, and we are going to get the answer. Okay. Now question number 5. Draw the decision boundary for k is equal to 1, k is equal to 3, k is equal to 5. Write the draw decision boundary function. This is an interesting question because it is going to employ your knowledge of visualization, how to create
the matplotlib.
the plot. Yes. So before you proceed this task, I'm going to give you a small hint. Since we have to create a decision boundary, that means we have to color the entire 2D array into exactly 2 colors. One color belongs to one class, second color belongs to second class. So we are going to color the empty spaces also, right, in the 2D space. Therefore, we have to calculate or predict labels for many number of points. Where those points will be very close to each other, so that it looks like they form 2 regions. And in order to do that, you will have to use mash grid from NumPy, and then predict the value for every point in that mash grid. Okay, so take 5 minutes and try to write the code for this one.
Actually, predict is written for a single point. That's going to make it really inefficient.
Right, right.
So instead of doing the point-wise boundary, can we maybe just do a colored plot of the predicted labels? The only
Colored.
problem is we won't be able to compare it with the y true.
Sorry, can you please repeat that?
The problem here is that we have to color the entire grid, not just the points, right?
Right.
Instead of that, can we color just the points? The predicted labels, that is.
The predicted labels for the entire grid, right?
For the entire data set, not the grid. Grid would take the xmin, xmax, ymin, ymax, the whole domain.
Yeah, yeah.
The whole range, that is. But since we have not written predict for a vectorized output, we'll have to loop through every single point in the entire mesh grid.
We have to loop through the entire. Yes, yes.
Unless we go back and rewrite predict for a vector also.
That is true. Right.
So instead of that, can we simplify the problem and just do a colored scatter plot of the predicted labels?
If we do only for the predicted labels,
we can't compare.
Right.
We can try plotting both things side by side and anyway.
So to get the points, you have to do much beyond X, right?
A little bit beyond X, yes. So you can add some margin like +2, -2, and similarly for y-axis also +2, -2.
Yeah, in this mean X1, X in the features, 2 features, right? Okay.
Right. Okay, so maybe let me start writing code for this one. The first step is to find out the largest and smallest values for the 2 features. So we can write x min y min is equal to np dot min x comma, I think axis should be by, so axis should be 0. Let's see if I'm doing it right. Okay, let me print those also. Okay, and similarly I can get the maximum values x min comma, sorry, not min, max comma y max is equal to numpy dot max, and let's copy the entire thing. Okay, so getting these values x min and x these values are going to give us some question, so that our figure is not just covering the data points. So if you don't add some question, what we are going to see, some of the data points will be lying at the edges of our figure. So to add the question, we can do this. The minimum values, let's subtract -2 or subtract 2, and for the maximum values, let's add 2. Okay, so this is what we are going to get. Okay, now what we have to do is we have to create a grid. Okay, and in order to create we have to first decide the resolution, how large our grid should be. So maybe we can create, let's say, 100 by 100. Okay, so I'm going to call the range of all the data points on along the x-axis tx. I can create n numpy dot linspace. I'm going to create it from x min to x max. Let's say I'm going to create 100 data points, and similarly I'm going to create it for y-axis. So instead of x min, I'm going to write y min, and x max I'm going to write y max. The number of points is still the same. Any questions so far?
Anyway, here axis equal to 0 is very important, right? Because otherwise you will not get the, so by default,
yes,
NP
yes.
min will just give a flattened this, right?
Right. That's true. Okay, so now we have this. Now the next step is, can anybody help me?
Flattened as a minimum of both the rows, is it? Both the columns?
Yes, x min is along x is equal to 0. That means first dimension, it is going to give us minimum values in both the columns.
Okay, thanks.
Okay. And if this is not helping, we can try it, let me quickly try it the other way. So let me write just numpy dot min of x, just first column. Okay, so all rows, the first column. Let's see what we are going to get. We are getting -7 point something, right? Here we got see -7.85, -9.85.
Yeah, minus,
yeah,
right?
exactly. So this is working fine. This is to just double check that our formula is working properly. Now we can do the same thing for second column also. Here we're getting minus 5.96, 7.96.
So should we just use x1, x2 instead of x and y, because it's actually, that is actually the right number, right? Because y is the label, so probably we just be.
That's a good point. That's a good point to avoid the confusion, right? So x min, probably give me one moment. I hope I have not used it anywhere else. Okay, I don't think I've used it. So I can replace with x1 min, replace all. Similarly, y min, I can replace it with
x2 min.
x2 min. Max to and x1 x. Okay. All right. So we have correctly renamed our variables now. Maybe I should call it tx1 and then tx2. Fine. What is the next step that I should execute?
Now get the label, predict the label actually.
Before predicting labels,
get
I
the
have
mesh
to
grid.
Mesh grid.
Mesh grid.
Exactly.
Yeah, okay.
Exactly. So I typically call it x1. I don't know. I have a habit of calling it XX and YY. Any other proper name you would like to suggest?
XX1, XX2.
XX1. Okay. Let's say XX1, XX2. All right. Here I'm going to pass TX1, comma TX2. So what it is going to what I'm going to get in XX1 and XX2 is they will be two-dimensional arrays of 100 by 100 each. So let's print their shapes and sizes just to confirm that we are doing the right thing. Print tx1 dot shape, comma xx1 dot shape. And for now, let's remove these. Let's see what. Right. So our tx1 has only 100 points. However, our xx1 is 100 by 100 points. And similarly, xx2 will also have 100 by 100 shape. Does anyone have any doubt why are we having 100 by 100 shape for xx1 and xx2?
Actually, I'm kind of mesh grid should. What does it do? It takes each point and gives a combination point.
Right, right. So what you can think of it, it takes the Cartesian product of these two sets. It takes 1 point from tx1 and see. So maybe I should show some of the values. Let's see. I can do that. tx1 first 5 values. So tx1 and let's see first 5 values from xx1 also. 5 rows and 5 columns. And before that, maybe it's a good idea to show right tx2 okay, and inside xx1 the first 5 values. Okay, so see this one, 0.98. Do you see this value?
Yes. Okay.
Right. see, it is being repeated over every row in the XX1. So 9.59, this value you're getting over here. In the next row, also it starts from over exactly here. Okay. And okay, in next row also it starts from here. Do you see the point of it?
This is that, okay, the straight Cartesian product. So that many rows, okay.
Right. So see, these first 5 values, the entire row, if you look at it, it is being repeated in every, these first 5 values are there in every first 5 values in XX1. Can you make this one? To tell you the truth, this XX1, the first entire row, not the entire row, I should say. TX1, right. So the entire TX1 you will find in the entire row of the XX1. Can you see it?
Yes, sir, but I didn't understand what we're trying to do.
Okay, so let me draw 2-dimensional geometrical figure. Maybe that could help. Give me one moment.
Actually, it's very much like drawing a bivariate heat map or something. So let's say you have a function which takes 2 parameters, x and y. And x goes from 0 to 10, y also goes from 0 to 10. And let's say that only integers are allowed. So overall on your paper, on your plane, you will have 100 points. Every possible combination. That's what this generates.
Yeah.
Yes, exactly. That's very well way to explain it.
Or maybe with fewer points, right? Maybe like 0, 1, 2, 3, 4. Suppose we have that till 10. Here I also have till 10. And I'm marking 100 points, right? 0, 0, 1, 1, 1, 2, 1, 3, 1,
1, 3, 1, 4,
2,
yeah,
1,
so on.
2, 2, 2, 3.
Okay.
All points, yeah.
Right.
And that through that linspace argument, I think we can change the, that's what I think linspace is doing there. The last one there is controlling how many points you want in the whole range.
Yeah, I just thought like doing
right.
with 10 points, it maybe the example may be better, right?
Okay, so yeah, good point. So let me explain that from with a smaller set of numbers.
And what will we need that for?
To create a decision boundary.
Oh,
Okay, so let me copy this entire thing, and this time I'm going to yeah, so let me copy this. Just copy this one. Okay, and instead of let's 0 to let's say 5, I need exactly 5 points. Okay, and here let's say from 10,
0 to 5, yeah.
10 to 15, so that we get different values for accesses. Otherwise 0 to 5, 0 to 5, that will be a bit confusing. That's all. 0, 1, 2, okay, maybe 4 values. Why are we getting things like that? 0. Oh, right. So this is sorry, I forgot.
This is not a range. This is linspace.
Yes. Thank you. So now it should give us the right values. Yes, 0 to 4. There it is. Okay, I think for this one I don't have to type :5 because the dimensions are that is not needed. Dimensions are small enough. Okay, can you see this now?
Yes, sir.
Okay,
so you want to split the next one?
See this one. So let's say assume that these two. This one XX1 has the x coordinate of every point in the grid. Okay, and this thing has the y coordinate of the corresponding point in the grid.
Okay, got it.
Okay, so this is the function of
X can only be in the range 0 to 5 and Y can only be in the range 10 to 15.
We have put
Exactly.
it that way.
Yes.
Okay. Okay.
Another way to look at that is that X is appearing in each row, the Y is transposed and appearing in each column.
Can you repeat that? I didn't get it.
I also probably didn't get it. So each row has the X repeated. Okay, that's the first dimension, right? And each column has Y transpose repeated.
Okay, right. That's one way to look at. Let me. So think about this way also. Let's say for first row, okay, first row of points, the X coordinates are 0, 1, 2, 3, 4, 5, and the corresponding Y coordinate is 10.
Okay.
So that is your lowest row, right?
Right.
Next row of points is the X coordinates are 0 to 5, and the Y coordinates are 11. That is your next row.
Okay. Okay.
Okay, and similarly we can do this, we can imagine this for every row in the data set in this mesh grid.
Okay, so if you print the last two arrays, it will come like a square of sort, filled square on a graph. Is that it?
Yes. So this particular one is definitely in square shape, but you can create rectangular grids also. That's not an issue.
Okay. Okay. Got it.
All right. So the entire purpose of creating this mesh grid is now we have coordinates of points for which we want to predict the labels with k is equal to 1, 3, and 5. I think that was the question. Yes, there it is. Okay, and let's say for 1 we mark it gray or red, and for 0 we mark it blue or something like that, so that we are going to get a nice colorful 2D chart.
But
okay,
to do the prediction, we need to call them one by one, right? That's what somebody was also saying, right? We took the predict the point is 1, right? We didn't take a vector for the point.
Yes. So far, yeah. So this for now we are not targeting efficiency. So we can ignore that part. We don't have to worry about that. We have to calculate predictions 1 point at a time. That's fine.
But actually, I'm very curious how maybe if in a couple of lines you could address that. Let's say my training data consists of 100 samples and my test data consists of 3 samples. So I should get a 100 by 3 distance matrix, right?
100 by, please. So 10 in test samples and 100 in training samples, is it?
Yes, 3 in test samples, 100 in training samples, let's say. So I should get a 100 by 3 distance matrix, which I can sort row wise, column wise, something and figure it out, right? The question is, how do you do that difference, especially the different distance calculation without iteration? What's the best vectorized way to
without the for loop, right?
Yes, yes. Yeah. Like in sklearn, there is some pairwise distance or something is there. Is there like an easy, because for L1, L2, both norms, we essentially need the distance, the difference part, x1 minus x2. That's the central thing we need. After that, the rest is easy. But how do you get that, n by k matrix out of just a difference operation?
Right. So I think there is a function called C distance IP.
C distance?
C distance IP. Give me one moment.
IP in NumPy?
C distance IP.
Oh, SciPy. C dist in SciPy. Okay.
So yeah. So if you
distance,
have, so we have 2 sets of points, then it is going to give you a matrix.
Okay.
Yes.
Perfect. Thanks.
Okay, so back to our question, we have created the mesh grid. Now what we want to do is we want to make the prediction. So for prediction, I'm going to use one of the solutions which I had written earlier. So this one. So this one is not the best way to do it, but it is going to work for now. It is slightly less efficient, but that's fine. Okay, now we have the mesh grid. We understood how the mesh grid works. Now it's time to predict for every value in the mesh grid the label for that point. Okay. So now tell me, how do I do it?
Yeah, zip it and then call, right? Zip x and next one, call predict function with that.
X1 and X2, yes, we can do that.
So flatten them and concatenate element wise, maybe.
Yeah, that is also going to work. So XX1 has the X coordinates, XX2 has the Y coordinates of the points. So what we have to do is first we have to flatten them. We can flatten them, that's no problem. So XX1 is equal to XX1 dot flatten. And similarly for XX2. Now, what do we do?
Iterate over both of them or
zip them, right? Zip each one, right?
Yeah.
Yeah.
But
zip
then
will
out
work,
of
right?
the
Or am I missing? Zip will work, right?
zip will work, but
Pardon?
you will get the X coordinate separate and Y coordinate separate, which again has to be put back into an array before passing to the predict function. Because
Yeah, then
XX
how else
one
do you
and
do a stack and then call it
Column
one by one?
stack.
yeah, column stack.
Right. So we can get.
Sir, I have a doubt.
Yes.
Sir, so what flatten does is that it removes the outer angular bracket, is it?
So let's say if we have 2-dimensional or 3-dimensional array, it will make a 1-dimensional array out of it. So let's see. Let's take an example. So this is XX1, right?
Yeah, yes,
This
sir.
one. Okay.
Yes, sir.
So let me print the flattened version of XX1. Okay. So instead of 1, flatten. See this one. This was 2-dimensional array, and the flattened version is this one. So it takes one row at a time and concatenates one after the other. So it becomes a row vector.
Okay, and in our case, it didn't change the dimension, it just removed the extra angular bracket outside, no? Or did it change the dimensions also?
It will change the dimensions also. See, so if I see the shape of this one, it is going to give me 5 by 5 or 6 by 6. Yeah, 6 by 6. So print the shape of this one, it is going to print 36 by nothing. There it is.
Okay. So now if we had done it for this mesh grid, then we would have had 25 values for points, right?
For this example that we are working on.
10,000 each.
And the previous one where we had 5 only?
6 by 6 points, right?
Okay, 6 points, right? So this would be 36 points, no?
Yes, there it is, 36.
Okay.
Okay, so we should move on. So first thing we have to do is we have to do numpy dot column stack. So it will be XX1, XX2. Got it. So now we have an array of, this should be, this should be an array of shape is equal to
10,000 by
10,000 by 2. Right. And now what we have to do is we have to pick one point from this array and use that where did our function go? Predict function and calculate the label. That's all we have to do. Right. So I'm going to, so in order to store the predictions, I'm going to create another array. So if I do this, if I flatten it, then I have to reshape it again. That's fine. So let's call it grid predictions is equal to numpy dot zeros like XX1. And then
XX1 dot shape or XX1?
So if I'm calling XX1, then it'll
zeros like, oh, I didn't know.
Oh, zeros like, okay, it's not zeros. Okay, thanks. Yeah.
it's not 0. Okay, so we have the grid points. Now what we have to do is for I in range, grid points dot shape 0, not just range, it should be length of this thing for every point. So one point would be grid underscore point. So this represents 1 point. We want to make the prediction on this one, so we call it predict x comma y comma k is equal to 1 for now. What is the, yes, this is the syntax.
Why flatten predictions?
Where did it go? Predictions flatten, so that we can use this I. See, so we have to store the corresponding predictions also, right? So I'm going to use something like this.
Won't it work even without that?
Without that,
because grid prediction size will be the ith row, right? Yeah, ith row.
Then we'll have to write nested loops, I guess. One for rows, one for columns.
No, there is like, okay, sorry, maybe see, because each of them have 10,000 rows now. Grid prediction, even if you don't flatten it, it's going to have 10,000 rows.
No, if we don't flatten it, then it will be 100 by 100.
No, 10,000 rows.
You're right, because
you already flattened x1.
X1 is already flattened, yes.
Yeah, thank you. Yes, you're right. Okay, so now we have predictions. We have made the predictions. Now what we have to do is we have to plot our chart. So plt dot okay, so what should I write in here? Can somebody help me?
Scatter xx1, xx2, y. Or should there be a tuple? No, c equal to y.
Yes, right? C is equal to grid predictions.
Grid predictions, yeah.
Comma, let's write alpha is equal to 0.5 something, so that it doesn't get just black and white altogether. Okay, I think we are missing.
Sir, what is alpha?
What is?
Alpha.
Transparency, right?
Yeah, transparency. Okay. Oops, this should be grid points. Okay, there is something wrong. It is saying
no,
object
not
of
len. No, there's no need for len, right? Just shape 0. There's no len.
Okay, right. Okay, so we got the answer and it looks like a good answer. So let's reduce the transparency even further. Okay, so we have a decision boundary. It is not making much sense because we have not plotted the original data points also. So let's do that.
No, but even this decision boundary is not good, right?
This decision boundary, well,
this look like a Norwegian fjords, no? Should be like more like a straight line, right? Some shape. It can't be like these things.
Yeah, I would say just by looking at the shape, we can do a comparison for k is equal to 1, k is equal to 3 and things like that. For finding out the best value, we have to do the cross validation.
And what k did we use here?
For now, k is equal to 1. So we got the most staggered decision boundary possible.
So I can understand why this is overfitting, right?
Yeah. So x is all rows, first column, and all rows, second column, color is equal to y. Right. So now okay. So the white points might not be that clearly visible. Is it making sense?
Yeah.
Okay. And
Can
here
we
you
make
can see
change the map to something else, like the color map to instead of gray and
yeah, that's what I'm thinking. So C map is equal to so always forget the names of the color maps. Yeah, there it is.
there is a function.
There it is. Okay. What is that function?
I saw it somewhere.
Okay, now it is looking very good. I can do the same thing for this one also. Okay, now now the yellow points are really bad.
Even without the thing, it was nice. Redis, even without Redis, it was very clear because only the.
Okay, so yeah, I think we can do that. Black and white for the decision boundary and colors for the points. Okay, makes sense. So this is for k is equal to 1. Let's try it for k
So
is
you know,
equal
obviously
to
something like that, inside island and all. That's actually not a good fit, right?
Pardon me?
See, among this one of the blues, one of the violets or whatever. Okay, is in an island of yellows.
Yeah, definitely. Islands for yellows, right? And there is one island for this purple also, right?
Yeah. So yes.
Yeah, not very good boundary. Visually, we can say that. So let's try it for k is equal to 3. Now we can see the boundary is smoother as compared to before. Or if you like, I can actually make it make those two side by side. Give me one moment.
Sir, why do we want the boundary to be smooth? I understand that very staggered boundaries might not do well for validation set, but again, I don't. Do we arbitrarily want the line to be smooth? If yes, why so?
No, I wouldn't say we don't want it to be too smooth that it forgets, it ignores the points, and we don't want it to be too sensitive to points. We want something in the middle. Okay, either way, if it is too sensitive or it is too ignorant, then our model is going to make bad predictions. It is going to ignore the underlying pattern. That is something that we don't want.
Yeah, in this model, we have not collected. Look at the error, right? Our model might have a lot of error.
Right. Good point. So we have not looked at the errors. Yeah, so that was actually the next task. Find the best value of k using 20% of the data set as the validation set.
So, sir, choosing a value for k here is like choosing a value for regularization in earlier problems.
Absolutely right. You're absolutely right. On spot.
Okay. And one question: why do we use ravel here and not flatten?
We can use both. Both do the same thing.
Else down the code there was a ravel.
Yeah.
Maybe
so
your
this
original
is the
code.
Right. So this is the original code that Sarah has used to record the videos. I just took it over here for the reference. And you would see it computes the distance matrix different. I mean, the distance matrix differently. So it considers all the points as row vectors. On the other hand, in this session, we have considered all the points as column vectors.
Yeah. Okay. And our this thing, everything, we already flattened all of them, right? So you don't need to do call the flatten, just call scatter.
Right. Okay, so now let's, so we have plotted for, we can do it for 1, 3, maybe let's say 6. Okay. What we can do is, okay, let's move this one out. Figure, to create a new figure, and then plt dot show. Let's see what we get. Okay, so this is for k is equal to 1. This is so the top one belongs to k is equal to 1, and you can see that the decision boundary is very sensitive. It is changing a lot when there is, wherever there is contention. In this one, the decision boundary is slightly smoother. So even though this purple point is misclassified, it is smoother than before. And if we go, if we increase the value of k even further, we will say we are going to have even smoother decision boundary. So this one only creates for three of them. Maybe we can create for more. Let's say 12. 12 is going to make a difference, and title k is equal to okay, there it is. For k is equal to 1, k is equal to 5, k is equal to 11. Oh, why it is changing? Yeah, k is equal to 3, k is equal to 5, k is equal to 7, k is equal to 9. Now you are going to see that it is actually not very sensitive. K is equal to 9, k is equal to 11. So as we increase the value of k, it moves away from overfitting. Okay, so I think we have already overshot our allotted time by 14 minutes. Any questions?
No, sir, it's quite clear.
Okay, thank you. So I hope this is clear. Now I'm going to give you a hint, and I would request you to try this last task out, which is the finding out the best value of k. So use 20% of the data points as validation set and fix the random state, and plot your accuracy or the metric that you want to take a look at, that you want to focus on along the y-axis, and on the x-axis the value of k. So for every value of k, you are going to get some loss function, value of loss function, and the value of k that gives you the least loss is the best value for this data set. This is how we are going to do it. And as it was mentioned earlier a few minutes ago, it is very similar to getting the best value of lambda, which is regularization rate in regression task.
Okay. The last function you said is the max error. They're just a difference, right?
Yeah, the accuracy. Yes.
Accuracy. No, yeah, they don't need for anything else.
Yeah. Okay. Thank you, everyone. I hope you enjoyed the session. I did. It was a great discussion.
Thank you so much.
Okay.
Thank you, sir.
And I sorry to embarrass Jaidev, but I think there is like maybe 100x difference between where Jaidev is and where I am in terms of NumPy. So hopefully I'll catch up.
Sure. I'm pretty sure you'll do, sir. Okay. Thank you, everyone. Have a good night.
Look,
Night.
so your name, sir?
Yes.
Yes, sir. So do you have any suggestions or tips on how to like prepare ourselves for the programming exam?
So the only suggestion is make sure that you understand the material properly, the techniques properly, the algorithms that have been. I'm saying algorithms as it is not an algorithm course, but every technique has corresponding algorithm to it. So understand those procedures, how they are executed. And if you've done the practice and programming assignments properly, then I think you will be in good shape for the exam.
Okay. Thank you, sir.
Okay.
Yeah. And I think if I can add a couple of points, I think, I don't know, whether Jaydev or somebody else posted, right? Writing the actual functions, because only week 1 to 4, right? And then the actual mathematical function and the Python equivalent of them. So practicing them again and again will help. And I think in a discourse thread, Karthik gave a few concepts of NumPy, right? Like, and then kind of try that out. So that might also help.
Okay, sir. Sure, sir.
By then, thank you.
Okay. Thank you, Srinivasan. Thank you, everyone.
Thank you. So,
Have a
sir,
good day.
just one thing I wanted to ask. On the graded assignment questions 1, 2, 3, there is quite a bit of confusion. So if you could.
Which week?
Week 7.
Okay, techniques. Okay,
Yeah.
go ahead. Tell me.
So the answers, I mean, there are a lot of posts on Discord as well. We're all getting different answers than what is given as the answer. So
Okay.
if you could just look into that, questions 1, 2, 3.
Okay, okay. I'll definitely take a look at that.
Sure. Thank you.
Okay.
Thanks.
Is there anything else we should discuss? All right. Thank you, everyone. Bye-bye.
Thank you. Thanks.
Thank you.